All right, guys, welcome to Unit 6 Quiz 2 Study Guide. On this video, I'll be going over the even problems from your study guide. Let's go ahead and begin. So the first question here, number 2, is asking us to factor out a common factor. In other words, we're just going to be looking for a GCF here, right? Usually when you're factoring, if it doesn't say that, you want to start with a GCF and go further. But with this problem, we're just going to do a GCF. So no need to go beyond that. So the first thing that we're going to do is we're going to set up our problem like this. We're going to be putting something on the outside of the parentheses there, and what's going to go on the inside is what's left. So what goes on the outside? Well, what goes on the outside is the number or variable that you can divide out of all three of these. Now the 3 doesn't have an x, so I can't take any x's out on this particular problem. But I do notice that 15, 6, and 3 can all be divided by 3. And so I'm going to divide those by 3. When you do this, you want to make sure you're dividing out the biggest number possible. And in this case, it would be 3. So 15 divided by 3 is 5. 6 divided by 3 is 2. And 3 divided by 3 is 1. And typically, if you can, you would want to take out some x's also. But as I've already mentioned, the 3 doesn't have any x's here. And so since we can't take any x's out of there, we can't take x's out because it has to be something they have all in common. So in this case, the x's will stay the same. And our answer would be this, which appears to be option number, or letter C there. All right, let's move on to our next even problem. All right, now for numbers 1 through 8, we're going to factor, but we're only going to have to factor once. Now, typically when you're factoring, the first thing you do is look for a GCF. And then after that, based on the number of terms that you have, you are going to do one of 3 things. If there are 2 terms, it's going to be possibly a difference of squares. That's where you have 2 perfect squares that are being subtracted. And when you factor those, you get one positive and one negative version of the square root of the values they gave you. If there's 3 terms present in your polynomial, then you're going to do the x and the box method. Finally, if there's 4 terms, you just do the box method. So just the box, that's it. No x on that one. Now, since we're only factoring once and we've already done GCF on numbers 1 and 2, we can skip this for now. So every problem we do is either going to be this one, or this one, and that's it. Now, when we get past number 8, we'll see that we're going to do a mixture of all these together. But in the meantime, let's just go ahead and see. Notice here that we have an expression that has 4 terms in it, so we're going to be doing just the box method for this particular problem. So how do we do that? Draw our box. Term with the biggest power goes in the top left. The term without any variables goes in the bottom right. The other 2 variables go in the other boxes. They're left over. It doesn't really matter which one goes where for those. The next thing we want to do is we want to take out what each row and column has in common, like a GCF. So what do these 2 terms have in common? 4 and 6 can both be divided by 2, and they also both have at least 2 m's in common, so I can put an m to the second power out there. Let's see what this row has in common. 10 and 15 can both be divided by 5, and since the 15 doesn't have any m's, I can't take any m's out. Let's go ahead and take a look at this column here, find out what we can divide there. 4 and 10 can both be divided by 2, and they both have at least 1 m. Last, we will look at this column here. Those 2 terms, 6 and 15, can both be divided by 3, but once again, no m's can be taken out because the 15 doesn't have any m's. You always want to go back and make sure you've done things right and it works out. So, for instance, does 2m times 2m make 4m to the third? It does. Does 2m times 3 makes 6m squared? It does. Does 5 times 2m make 10m? It does. And then finally, does 5 times 3 make 15? It does. You always want to check because if you've made an error, that's where you'll catch it, okay? So in any event, The four-termed polynomial now is factored into two polynomials that are binomials. We have a 2m plus 3 from the top and a 2m squared plus 5 from down the side there. And let's go ahead and see which one of those it is. It looks like it would be option part A there. Notice the order is different than I wrote it here, but that doesn't matter. With multiplication, order doesn't really matter. All right, so that takes care of number 4. Let's go ahead and move on to number 6 here. I'll leave our chart up there though so that we know which strategy to pick. Right, number 6. All right, number 6. Once again, we're going to skip the GCF, and it's going to be one of these three. I noticed that there's two terms here, so that's if it's going to be anything at all, it's going to be a difference of squares. So how do we do the difference of squares? First of all, are these both perfect squares? Yeah, you could take the square root of 9, that gives you 3, and you could take the square root of 4, that gives you 2, right? So we could split these things up. One's going to be plus, one's going to be minus. So what times itself would give you 9v to the second power? Well, the square root of 9 is 3, and if we split up the v to the second power, it's just v. So we'll put that in the front of each pair. Then we'll take the square root of 4, which is 2. And we're looking for 3v plus 2, 3v minus 2, and that would be option D. Let's go ahead and take a look at our next one, number 8. Okay, so notice this time it has 3 terms, which means we're going to be doing the Xbox method. So, how do we do the Xbox method? Well, let's review. You take the first coefficient and you multiply it times the last number. 4 times negative 25 is negative 100. And you take the middle number and you put it on the bottom. Now we're looking for two numbers that multiply to make 100 but add up to make 15. So let's go ahead and start with 100. What number pairs are there that we can multiply together to make 100? Well, there's 1 and 100. There's 2 times 50, that makes 100. 3 doesn't work. 3 doesn't go into 100 evenly. But 4 does. 4 goes into 100 25 times. 5 goes into 100 20 times. 6, 7, 8, and 9 don't work, but 10 does. 10 times 5 works. And I'm pretty sure that's going to be our last one. 11 doesn't work, and 12 doesn't work. So I think, and since we have a repeat here already, matter of fact, I think I got a mistake here, my bad. This isn't 5, it would be 10. Let me fix that. 10. All right, 10 times 10 is 100, not 10 times 5. All right, and as soon as you get a repeating value somewhere, you've found as many pairs as you can. So these are all the different pairs that can multiply to make 100. Now it's got to be negative, so when I multiply these, one of them has to be negative, but we'll decide that in a minute. Now we want to figure out which one of these pairs can also add or subtract to make 15. There's no way you can add or subtract 1 and 100 to get 15. How about 2 and 50? Nope. 4 and 25? Nope, not quite. 5 and 20 can give you 15 though. 5 and 20 can give you 15 if you make the 5 a negative. That way, 20 plus a negative 5 makes 15, and also 20 times a negative 5 makes a negative 100. So we found the number pairs that work. Now we do our box. We're going to put the first term in the upper left square. We're going to put the last term in the lower right square. And then we're going to put these two numbers in the other squares. But next to them, we're going to include whatever letter's in the middle. In this case, it's a K. So we'll put a K there. And now we're going to do the same thing we did with the polynomial that had 4 terms. We're just going to take out what they have in common. So here, 4 and 5 can only be divided by 1, but they do have a K in common. So we could take out a 1K. Here, 20 and negative 25 can both be divided by 5. Here, 4 and 20 can both be divided by 4, and they both have a K also. Finally here, 5 and negative Negative 5 and negative 25 can both be divided by 5. And since they're both negative, we'll go ahead and take out a minus also. So this one comes out to be k plus 5 times 4k minus 5. Let's see, I think that would be option C there. All right, so those are all of our factoring strategies. Now, for these first 8 exercises that we have done, we've only done one factoring strategy. So for numbers 1 and 2, we were just taking out a GCF. And then for numbers 2 through 8 there, we were doing one of these 3. But now, whenever you're factoring in general, sometimes you have to factor more than one time. You can't do it just once and be done. You have to analyze it and kind of see. So now we're going to make our chart a little bit more complete for this next exercise. We do want to start by looking for a GCF. That'll be our first step. After that, depending on how many terms it has, 2, 3, or 4, we'll use one of these strategies. And even after we do that, we may get to do it again. So let's go ahead and see where this goes. So we'll start here. Let's start by looking for our GCF. Is there a GCF? There may be or there may not be. It turns out that there is a GCF here on this problem. They don't both have a k, so I can't take any k's out, but they both can be divided by 2. So I can take a 2 out, and I'm going to divide it out when I do that. That's going to leave me with 4k to the 6th power minus 9. Now I'm going to look at what's left here, 4k to the 6th minus 9, and I'm going to see which of these strategies I can use on that. Well, since it has 2 terms, we're going to check to see if it's a difference of squares. Well, it depends. Can I take the square root of these numbers? Yeah, I can. The square root of 4 is 2, and if you take k to the 6th and split it up evenly, you get 3, right? So it's going to be 2k to the 3rd for the first term there. And for the second term, the square root of 9 is 3. Now, sometimes you could even keep going more. How do you know when to stop? Well, if you ever have like a first degree binomial, then you can stop. But this is a third degree binomial, so we might be able to keep going. Same thing here. This is a cubic binomial. So cubic means the highest powers of 3. So these might be able to be factored more. But if you ever have a linear polynomial where the highest powers are 1, those are done. You can't factor those anymore. But in this case, we should check. So since they have 2 terms, I would think to myself, well, are these a difference of squares? Well, first of all, this one has a plus. So that's not a difference of squares. We can't do that one. So this one is officially done. Let's take a look at the next one. This one is a difference. But it's still not a difference of squares because 3 doesn't have a nice square root and neither does 2. So we are done with that one also. But you do want to keep checking until you know you can't go any further. But in this case, we are officially done, and the answer would be D. So just keep factoring and applying those rules until you can't apply them anymore. All right, now we're going to get into our review questions. This is a review question from Unit 1. It's solving a linear equation. When it comes to solving linear equations, we have some steps we're going to follow. We're going to start with some distribution. After that, we're going to combine like terms. There's 2 steps to that. Once when they're on the same side and once when they're on opposite sides. After that, you'll go ahead and get the variable by itself. Okay, so we have these, we'll call them 3 steps, where step 2 kind of has 2 parts to it. All right, let's begin. So let's see here. We do have distribution to do. Anytime you have parentheses with a number in front of it, we're going to distribute. So I'm going to take this 7 and distribute it into these parentheses here. That's going to give me negative 21 plus 14r equals, and here you can think of this like a negative 1. We're going to distribute that also, and that's just going to change the signs. Now we're going to combine like terms. So we start by combining like terms that are on the same side of the equal sign first. On this side, I do have 2 like terms that I can combine, the negative 8 and the 14. Negative 8r plus 14r is 6r. So we have negative 21, and then when I combine these two, I get 6r. The next thing we do is we combine like terms that are on opposite sides. So on this side and this side, they do have some like terms I can combine. We can combine the 6r's. So I'm going to minus 6r on both sides. And something interesting and unique happens here. They both cancel out, and I'm left with this. Now, whenever your variables go away, that either means no solution or it means all real numbers. If you end up with a false statement like this one, the answer is no solution, right? So I don't get to do step 3 on this because my variables canceled out before I got there. But if you still have variables, you would start getting the variable by itself. But in this case, we saw that we ended up having no solution. All right, let's go ahead and take a look at number 14. Number 14, the directions. Let's take a look at those really quick, if it'll show them to us. Okay, it won't show it. It's on the last problem, though. We'll back up to read the directions. For numbers 13 through 14, find the value of x for the system of equations, and we need to decide whether it's best to use substitution or elimination. Okay, so now systems of equations is when you have two variables with two equations, and you want to find out what is the value of x and y that works for both equations. We learned two methods, substitution and elimination. We learned that when the variables are lining up like this, the like terms are lining up, that's a time to do elimination. All right, so let's go ahead and review how to do that. If you guys want to see your notes on this, that was Unit 5. If you wanted to take a look at Unit 5, you'll find lots of examples of how to solve equations like that. And specifically, this one would be 5.2 if you wanted to look at that lesson in your notes. But let's go ahead and get started here. So the first thing you're going to do when you want to solve a system of equations is you want to pick a variable to cancel out. Now, since the problem is asking me to solve for x, I'm going to choose to cancel out the y values here. Because I don't mind getting rid of the y's because I really just want to find x. So what do we do now to cancel out those y's? What we're going to do is after we pick a variable we want to cancel is we're going to flip and distribute the coefficients. So I'll demonstrate what I mean by that. So my coefficients on the y's are -8 and -6. I want to flip them. So the -6 is on the bottom, but I'm going to put it on the top. The -8 is on the top and put it on the bottom. So I'm going to flip them. And now I'm going to distribute them. I'm going to multiply them all the way across these equations. And what that's going to end up doing is it's going to give me a situation where the y values are equal. Now I've got some pretty big numbers here, so I'm going to need to use a calculator for this part. So I'll go ahead and pause the video here and I'll work these out. But I'm just going to multiply the top by 6 and the bottom, -6. And I'm going to multiply the bottom by -8. And when I unpause it here, I'll have the answer up. So if you guys want to pause it and try it too, you can. And there's a result. Now you guys can see the y values are the same, but I want them to become opposites so they'll cancel. So now I'm going to pick one of the equations. I'll do the bottom one and I'll multiply it by a -1. And what that's going to end up doing is just changing all the signs. So we're going to distribute that, and it's just going to cause all the signs to change. Now to help me save some space, I think I'm just going to go ahead and change those signs myself right here using my computer. So the 48 now on the bottom will be negative, the 72 becomes positive, and the 216 becomes negative. All right, so after you distribute a -1, you're ready to combine your equations together. So we're going to add these two things together. So what is -108 plus 72? I think that's going to be -36 if I'm not mistaken. Let me make sure. 28 plus 8. Yeah, 36. All right. And then I'm going to combine these together. And when I do, that's what I want to happen, is I want them to cancel out. And then on this side over here, if I combine these together, I end up with -108. If I combine these together, -216 plus 108 is -108. Now we're going to solve for x by dividing by -36. These go away. And I'm going to guess here that this is going to be negative divided by negative is positive, and 36 goes into 108 3 times. Now, technically it is possible to get a decimal on these questions, but remember, I won't be giving you questions that do that. So if you get a decimal here, something went wrong. We got a nice solid whole number here, and that's our answer for x. Now, if you made a mistake and accidentally solved for y, it's okay. Just take your answer and plug it into one of these equations to find the variable you need. But in this case, I'm not going to do that because I just needed x and I've got my answer. All right, let's go ahead and move on to number 16. Number 16 is asking me to sketch a graph of the line. Now, in order to graph the way that we learned in class, we need it to be in y equals mx plus b form. So I need to change this equation so it's in the right format. So when we did this, I asked you guys a series of questions. My first question was, what side of the equal sign is the y on? In this case, you would say, oh, well, Mr. Bailey, it's on the right side of the equal sign. And then I asked you, are there any other terms on that side other than the y term? There is. Here's my y term, but we also have an x term and a constant. So we have two other terms that are on the same side. Well, I want to get rid of those. I don't want those terms there. And the way that we get rid of those terms is by doing the opposite on both sides. So I'm going to add 6x on both sides. That gets rid of the 6x. And now I've got a 6x on the left. And I also want to get rid of that 2. So I'm going to subtract 2 on both sides. So now that's gone. I cannot combine these because they're not like terms. So I'm just going to put them next to each other like that. The next thing we need to do to get the y by itself is we need to get rid of the coefficient. The way that you get rid of the coefficient is you divide everything by that coefficient. So these go away and I've got y. 2 divided by 2 is 1 and there's a negative in the front. 6 divided by 2 is 3. Now sometimes you're done, by the way. There's your y equals mx plus b. Sometimes though, right here, just be aware it doesn't always work out that nicely where 6 can be just divided by 2 and you get a nice number like I did. Sometimes you'll get a fraction. You just want to make sure that you reduce it, okay? But we've got our y equals mx plus b form. Y is equal to 3x minus 1. So we have this. This is going to be an easier thing to use to graph. I can see now that my y-intercept is -1, so I'm going to put a dot at -1. And I can see now my slope is 3 over 1, so I'm going to go up 3 over 1 from my starting point, and I'm going to connect my dots. And from there, I should be able to identify the correct option, which would be A. All right. There you guys go. Hopefully that was helpful, and we'll wish you guys luck on your quiz. See you then.